Hi, thank you for joining me on this question. I'm going to look at a question where a girl is swinging on a maypole in a playground, and she's 30 kilograms, and the rope is 2.4 meters long at an angle of 60 degrees to the horizontal. So let us look at these figures. So I'll just draw a quick picture, and we've got the circle here, and we've got the girl here, and our force due to gravity is down. Our normal force is along the rope, and then we've got this net force which is towards the center. And so the three forces are net force, so I'll put that here, normal force, the force due to gravity, and the net force towards the center. That's point B. And let's look at some lengths here, because we've got a 60-degree angle in the picture, and this is 2.4 meters. So it's asking what's the radius, and the radius is using cos 60. You can get adjacent over hypotenuse in that triangle just for the length, and therefore the radius is 2.4 times cos 60, which cos 60 is a half, so the radius is 1.2 meters. So calculate the radius of a circular path, it's 1.2 meters. Identify the forces that are acting on her as she swings freely. Well, I've already put those forces on the diagram, and so there's the three forces: the normal force, the gravitational force, and the net force towards the center. I'll put F-N-E-T. What is the direction of her acceleration when she is at this position? Well, there's an acceleration towards the center. The acceleration is the centripetal force towards the center of rotation. So there's the circle, and the center of rotation is towards B. And that's part C. I'll just put the acceleration is acting towards the center of the circle, your motion towards the center of the circular path, which is towards B. That point B. Calculate the net force acting on the girl. Well, the net force will use this triangle here, and we've got the gravitational force is mg, and so that is her mass times gravity. Her mass is 30 kilograms. So 30 times 9.8, that's her force down. And we've got this angle of 60 here and an angle of 30 there. And so using tan theta, tan of 30 is opposite F net over adjacent, which is a gravitational force. And so tan of 30 is equal to our net force divided by 30 times 9.8. And we can bring 30 times 9.8 to the top here, 30 times 9.8, and tan of 30 is 1 over root 3. So let's put that into the calculator. And we got 30 times 9.8 divided by square root of 3. So we've got our net force of 169.74 newtons acting towards the center of pathway, which is towards B. Finally, what is the speed that as she's swinging? Well, the speed we can say will be mv squared over r is equal to our centripetal force, 169.74. So let's put our mass, which is 30, v squared over the radius, which is 1.2, is equal to 169.74. So v squared equals 169.74. Bring that divide 1.2 up to be multiplied. Bring that times 30 across to be divide. So we get that, and we're going to get the square root of this result. I'll just put whatever that answer is. So 169.74 times 1.2 divided by 30, and we want the square root of that. Oh, error. Try again. Square root of 169.74 times 1.2 divided by 30. And we've got approximately, I'll change that to approximately, 2.6057 meters per second. And let's just make that approximately 2.6 meters per second to 1 decimal place. So I hope this has helped. Until next time, stay happy.